Hi, it's me, Jacob. Behind me is a skid steer loader. Designed to be versatile and maneuverable, this piece of equipment is a staple in your every modern day construction site. Normally operated from inside the cab, remote control operation of this machine do exist for some applications. Bobcat, for example, sells their own plug-and-play remote control module for some of their skid steer loaders. But these do typically cost a lot of money and may or may not ship to where you might be. So in this video, I'll show you how to make your own do-it-yourself remote control module using an Arduino, a remote control transmitter and receiver, some wires and connectors, and a bit of know-how. Quick disclaimer though, this is not a manufacturer-approved modification. The OEM or myself will not be liable for any machine damage or injury that might be the result of copying this process. Consult a qualified technician if you want safe and reliable results. Let's get a better look at the machine first. Movement of this loader is controlled by two joysticks. A typical format uses the left stick for drive, forward and back, and steer, left and right, and the right stick for boom and bucket. These joysticks signal the computer inside the machine, and it communicates with the hydraulics what you want to happen. The joysticks are typically connected through a harness of some sort. To verify which wires do what, we look at the schematic diagram. This wire is your ground, this is your 12-volt power, and these are your X and Y axis signals. Let's hook up some oscilloscope probes on the signal wires to see what's actually going on. From what we can see here, the signal wires are getting a PWM signal. The position of the joystick along its X and Y axes changes the duty cycle of these signals. This is what is being read by the computer, and if we can replicate this signal, we essentially replace the joystick's role. Let's take a closer look at our PWM signal. It is important to replicate this precisely because the computer will give you error codes if it sees something is off from the signals. It is a 5-volt signal at 500 Hz, and it varies from 80%, 20% duty cycle. Luckily enough, the Arduino Uno we're using also spits out a 5-volt signal at 500 Hz. Now that we know what we want to create, let's now talk about how we're going to replicate this remotely. This is how the cab operation goes. Operator input, joystick changes to PWM, and we get movement. And this is how remote operation goes. Operator moves the radio joysticks, the radio sends a signal to the receiver, which becomes the input of the Arduino, which translates it to the proper duty cycle. Now let's take a look at how we're going to code our Arduino in order to translate those radio signals into our PWMs. The most important part of the code is definitely the setup. This is where you will be defining your constants, your variables, as well as your different pin modes. Depending on the type of Arduino board you're using, and the amount of additional features that you might want to control in the machine, your input and output pins might look a bit different from what you see here. It is also important to know the high and low state of the radio that you are using, to be able to match that to the low and high duty cycles of the machine. The logic train to accomplish this is fairly simple. First, we have a portion that reads our receiver signal, another portion of the code to make sure the signal is within range, a portion of the code to calculate the output signal, and then a portion of the code to actually output the PWM. Now, since our skid steer will be using 4 different signals, repeat the code 4 more times using the appropriate variables and values. Now, copying and pasting this code line for line won't guarantee results. Understanding how the functions, variables, and conditional statements work inside the code will help you tailor fit, modify, and debug your code should you run into any issues in the future. I used a screw terminal block prototype shield that can mount directly on the Arduino Uno. I chose this instead of just the pins because the screw terminals make sure that the wires are secure and won't go loose on you while you operate the machine. You can use whatever wire you have available that you think is robust enough for your needs. The harness connectors on the machine are Deutsch connectors, but yours might be slightly different. Screw, solder, and hook everything up. Package it up to the build quality you desire, and you now have a remote-controlled signal-generating unit. Now to safely test it out, I recommend putting it on blocks to see if all the functions are operating predictably before testing it out on the ground. Once everything checks out, Time to do some practice. Now, obviously from the footage I'm showing, why not just hop in the machine yourself if you're going to be operating it from just a few feet away? Now, this allows people with disability who aren't capable of hopping in to operate the loader. And also, this also allows the operator a different point of view when operating the machine compared to if he was sitting in the cab.
So what I've done here can obviously be improved upon. Like with additional relays, you could potentially control the ignition system, start and stop the machine from the remote itself. You could also use a megaboard and control all the bells and whistles, such as the auxiliary hydraulics on it, the horn, and whatever else you would like to control.
You could even potentially slap in a live feed camera system and control it as how you would pilot a drone. With enough understanding of how electronics work and the right amount of creativity, we can continue to develop new ways of doing things. I'd like to end this video by thanking Centennial College for providing a valuable piece of equipment to work on, and to Professor Tim Allen for providing the valuable mentorship, the necessary tooling, and making sure you execute the project safely. That's it for the video. Thanks for watching.